Dear students, I am Dr. Tamrakar from Bhartiya College of Agricultural Engineering, Durg. I will teach theory of machine of BTech first year, second semester class.
Dear students, today we will solve some numericals that have been asked in the university examination. A single plate clutch with both sides effective has outer and inner diameter 300 mm and 200 mm respectively. The maximum intensity of pressure at any point in the contact surface is not to exceed 0.1 Newton per mm square. If the constant of friction is 0.3, determine the power transmitted by a clutch at a speed of 2500 rpm.
The data given here are D1 equal to 300 mm. So R1 equal to 150 mm, D2 equal to 200 mm, means R2 equal to 100 mm. P intensity of pressure is equal to 0.1 Newton per mm square. Mu is given 0.3, N is given 2500 rpm. So here omega equal to 2 pi n by 60. So this is 2 pi into 2500 by 60. So this value of omega comes 261.8 radian per second. Since the intensity of pressure here, intensity of pressure is maximum at inner radius, Here, intensity of pressure is maximum at inner radius R2. So, for uniform wear, P into R2 equal to C, that is equal to P is 0.1 into 100 is R2. So this is 10 Newton per mm is C. We know that axial thrust W equal to 2 pi C R1 minus R2 putting the values here. 2 pi into value of C is 10, R1 minus R2, 150 minus 100, so this value of W comes 3142 Newton, and mean radius of friction surface for uniform wear is R equal to R1 plus R2 by 2, that is 150 plus 100 by 2, that is equal to 125 mm, equal to 0.125 meter. We know that torque transmitted that is T equal to N pi WR. So here number of plates of 2 pi, value of W is 3142 and R is 0.125. So this value of torque comes 235.65 Newton meter. And power transmitted by clutch equal to T omega equal to 235.67 into omega is here 261.8 radian per second equal to, this comes 61,693 watt or 61.693 kilowatt is the value of power. So we have to solve some more numericals of this topic. We will solve one more numerical. This one has been asked in the university examination twice. A single dry plate clutch transmits 7.5 kilowatt at 900 rpm. The axial pressure is limited to 0.07 Newton per mm square. If the coefficient of friction is 0.25, find first mean radius and force face width of the friction lining, assuming the ratio of mean radius to the face width as 4 and outer and inner radius of the clutch plate. Here the data given are P equal to 7.5 power equal equal to 7.5 kilowatt. This one is power. That is equal to 7.5 into 10 to the power 3 watt. Then N is given 900 RPM. So the value of omega is equal to 2 pi 900 by 60. So this comes 94.26. 94.26 radian per second. Radian per second. And intensity of pressure small p is equal to 0.07 Newton per mm square, and mu equal to friction given 0.25. Now we have to calculate mean radius and mean radius and face width of the friction lining. Face width of friction lining. Friction lining. So here let R is the mean radius of friction lining in mm. Mean radius in friction lining in mm, and W is face width of friction lining in mm. Ratio of mean radius to face width is given. Ratio of mean radius to face width, this is possible, width is given as 4. We know that area of frictional faces, area of frictional faces area equal to 2 pi R W. So normal or axial force acting or axial force acting on frictional faces that is W, equal to A into small p is equal to 2 pi R W into small p. We know that torque transmitted considering for uniform wear T equal to N mu W R equal to N mu and 2 pi RW small p into R. So this is torque equal to N mu taking common 2 pi R R by 4 the value R by W. So the value of W is R by 4. This value of W is R by 4 into small p into R. So that is equal to pi by 2 this cancel. Okay, so this is pi by 2 and mu small p R cube. This is R, and this is R. So this is R cube. Now putting the values here, pi by 2 and N is 2, mu is 0.25, P is 0.07, and the value of R is, we have to find, this is R cube. So this T equal to 0.055 R cube. We also know, this is equation 1. We also know that the power transmitted P, power transmitted P, this one is capital P, is equal to T omega, the value of T is 7.5 to 10 to the power 3 equal to T omega, T into omega, value of omega is 94.26. So here the value of T 7.5 into 10 to the power 3 by 94.26. This comes 79.56 Newton meter, or can also meter as 79.56 into 10 to the power 3 Newton mm. So from equation 1 and 2, putting the values of T there, R cube equal to 79.56 into 10 to the power 3 by 0.055. So the value of R comes 113 mm is the one answer. And for W equal to R by 4, that is 113 by 4. So this width comes 28.25 mm is the value of width. Now the outer and inner radii of the clutch plate, second outer and inner radii of plus plate Let R1 and R2 are outer and inner radii of the crust plate respectively. Since the width of crust plate is equal to the difference of outer and inner radii. Difference of outer and inner radii. Therefore, W equal to R1 minus R2 equal to 28.25 mm. Also uniform wear, the mean radius of crest for uniform wear the mean radius is equal to R1 plus R2 by 2. So R1 plus R2 equal to 2R, that is equal to 2 into 113 equal to 226 mm. Now from these two equations 3 and 4, solving these two, okay, R1 plus R2 and R1 minus R2, the value of R1 and R2 comes as R1 equal to 127.125 mm and R2 comes 98.875 mm. Okay, so you have to solve some more numericals. You have to practice on solving of different questions that have been asked in the university exam. That will be beneficial. Thank you.